All right, now in this example, I'm just going to go through another polynomial and try to find all of the real zeros, okay? So again, I'm going to start off by identifying the maximum number of real zeros I could have is 3. And I can find the possible rational zeros by taking factors of the constant, dividing them by factors of the leading coefficient. Okay, so I'm going to look for my p's, which again are the numerators on the rational zeros. Those come from the factors of the constant, and my q's come from factors of the leading coefficient. Now, it's a much smaller list than what we've been seeing. 1 and 5 and 1 and 3. Okay. Now, if I want to find all the possible combinations of p over q, then I'm just going to take 1 over 1, 1 over 3, 5 over 1, and 5 over 3. Just 4 combinations. So plus minus 1, plus minus 1/3, plus minus 5, and plus or minus 5/3. Okay. So now as I look at that, I'm going to start plugging those numbers in, right? I've got 8 possible things to plug in, and we'll see if any of them work out nicely. Let's try the 1 first of all. If I do f of 1, that's going to be 3 minus 1 minus 15 plus 5. Unfortunately, the negatives clearly outweigh the positives, so this is not 0. So positive 1 does not work. If I try negative 1, I'm going to get negative 3 minus 1 plus 15 plus 5. This time the positives outweigh the negatives, and so neither of the 1s will work. Okay. Alright, now we could try the 5s. The 5s are going to take a little bit more work. I'm trying to skip the fractions here just to make that work out a little bit nicer. So if I try the 5s, well, if I plug that in, that's 5 cubed is 125 times 3. 125 times 3 is 375. Again, I'm working with a positive 5, so positive 5 squared is 25, so minus 25. 15 times 5 is 375, so that's a minus 75, and then a plus 5 on the end. Well, here I can clearly see that the 375 is bigger than my negatives combined, which equal 100, so definitely the positives outweigh the negatives, and that won't work. If I try that with a negative 5, it just changes all the signs on the odd degree terms. So this would be negative 375 minus 25 plus 75 plus 5. Again, the negatives certainly outweigh the positives, so the 5s don't work. Okay, so now we got to go to our fractions. Let's start with a positive 1/3. So let's do f of 1/3. Well, 1/3 cubed is 1 over 27. So it's 3 times 1 over 27. Then I've got 1/3 squared is 1/9. 1/3 times 15 is 5. And then the plus 5. Well, my minus 5 plus 5 drop off nicely. And here in this first term, 3 times 1/27 is 1/9. And I still have a minus 1/9. Well, those drop off, and I do get 0. So 1/3 is definitely a real zero, or a rational zero, in fact, of this original polynomial. Now I could take that original polynomial and continue to plug in my other numbers, which might be a pretty quick way to do that. So I'll start. Positive 1/3 does work. Let's go ahead and finish that off. Let's do negative 1/3. And of course, all that does is it changes the sign on the odd powered terms, odd degree terms. So that would be negative 1/9 minus 1/9 plus 5 plus 5. Well, here the positives outweigh the negatives, so that one's not going to work. Okay, so I can get rid of that. Negative 1/3. Remember, I have as many as 3 possible rational zeros here, so there's only 2 left to try. Let's see if they work. There's no guarantee, because I could have repeated zeros, I could have some irrational zeros. So let's just give it a shot and see if 5/3 will work. So that'd be f of 5/3. Wow. Okay, so that's going to be 3 times, what's 5 cubed is 125, 3 cubed is 27, so it's 125 over 27 minus 25 ninths when I square the 5/3, then minus 15 times 5/3, and then plus 5. Now as I simplify this, we'll just try to keep track of our positives and negatives, see if they drop out, if they even up. So 3 over 27 is 1/9, so that's 125 over 9 minus 25 over 9. Here my 15 and my 3 cancel to a 5, so it's minus 25 plus 5. Let's see, the fractions add up to 100 over 9, which is, what, just over 11? 11 and 1/9. These combine to be a negative 20. So positive 11 roughly minus 20, definitely the negative outweighs the positive. So that one does not work. And if I try that with a negative, let's switch the signs up a little bit here. I'll switch the color when I do that. So if I try this with a negative 5/3, it's going to change the sign on my odd degree terms. Okay, so this will become a negative 125 and a positive 25. Let's see. So that combination would be negative 150 over 9 plus 30. Well, 150 over 9 would have to equal, oh, it is negative, would have to equal 30 for that to drop off, and it doesn't. 9 goes into 150. Well, not quite even, not even 20 times, right? So that's not going to work. So this is not, neither one of those are going to work. So right now I only have 1 rational zero out of my whole list. Okay, well that's unfortunate, but that's okay. So now we're going to have to assume that the other 2 zeros, or 2 potential zeros, they're either going to be complex zeros, which we're not going to really deal with, or they're irrational numbers, okay, irrational zeros, or it's a repeated zero, okay? Well, it could be an irrational repeated zero. Definitely isn't going to be a rational number though, okay? So how would I find them? Well, I'm going to reduce this down to the depressed polynomial by synthetically dividing by the 1/3. Okay, so I have 3, negative 1, negative 15, and 5. All right, so now I'm going to bring down my 3. 1/3 times 3 is 1. Negative 1 times 1 is, or plus 1 is 0. Multiply to get 0. Subtract 1/3 times negative 15 is negative 5. Remainder 0. So what do these numbers represent? They represent the depressed polynomial. It means that my original polynomial factors into, well, the x minus 1/3 times the depressed polynomial, which is 3x squared, right? 3x squared, 0x minus 15, remainder is 0. So the 0x I don't need to include. This could be a minus 15, all right? Okay, well at this point I can already see I've got a common factor of 3. If I pull that out, that's going to simplify things a little bit. So let's do that. I'll pull a 3 out. I'll pull it all the way out front just to get rid of it. Move it a little bit further away, and I get x squared minus 5 when I do that. Okay. Well, to find the zeros of this part, the depressed part of the polynomial, I just set it equal to 0, x squared minus 5, set it equal to 0, and solve for x. Okay, so add 5, we get x squared equals 5, which means x is plus or minus the square root of 5. Square root of 5 is an irrational number. There are two irrational zeros. One is plus root 5, one is minus root 5. And that makes sense because along with the positive 1/3, that gives us our 3 real zeros, okay, for our third degree polynomial. So everything's matching up nicely. So if I want the real zeros, they are, what, positive 1/3, positive root 5, and negative root 5. And if I want to use them to factor the original polynomial, I can do that. The original polynomial factors into 3. 3 times x minus 1/3 times x minus root 5 times x plus root 5. Okay? And of course, if I wanted to, I could distribute the 3 into that first set of parentheses just to get rid of the fraction there. So I could call that 3x minus 1 after multiplying, distributing the 3, and then you get x minus root 5 and x plus root 5. Okay, so either of those would be sufficient. I kind of like the first one there so that I can actually see with my eyes all of the rational zeros that occur. Okay, or actually all of the real zeros. Sorry, 2 of them are not rational. Okay, so that gives you an overview, different techniques you can use. Really, we're starting off these problems by using the rational zeros theorem, finding all our possible rational zeros, and then plugging them in one at a time till we get zeros popping out. Okay, once you start getting zeros popping out, you can either continue to try to find more, which is what we did here, or you can take the zeros that you find and reduce the original polynomial into a depressed version, which you could then try to solve in other ways. Okay, so the process, the main goal is to try to start off with the rational zeros and then reduce the more complicated polynomial down to something simpler that you can deal with a little bit faster. Okay, lots of cool stuff in these examples, and I hope that helps to clarify some of these theorems for you.